Hello everyone. I'd like to demo a project I've been working on called WebForecasting. As you can guess by the name, the purpose of the project is to generate forecasts, specifically for time series data. So to demonstrate it, let's get some time series data. What I'm going to do is go get some historical data from Apple's stock data on Yahoo Finance. And I'm going to get 5 years of daily data and download it. Then we're going to open up the CSV, get rid of these columns. I just want the close and the dates. And then we can just paste it in to this box right here. And it graphs it. So this is just the data by itself. Now from these drop-down menus, we can choose some curve-fitting method to generate the forecast. Let's start with something simple like a linear regression. So the green line is the linear regression, and it's based off of the last half of the data. And that way we can do backtesting when you don't use all the data. And then the red lines are corrected versions of the generated forecast based off of the backtesting, where this top line here comes from the 95th percentile of the residuals from backtesting, or the P95. And then this middle line is the P50, and then the bottom line is the P5. And then we can also try a couple of other curve fitting methods. We've got polynomial and exponential. Now, in case you're not familiar, I'd like to go in a little bit more depth of exactly what it's doing with the backtesting. So let's come over to this other thing here. So let's talk about a much simpler data set. We've got 12 points here. And if we're going to use let's pretend a human can do a linear regression, and that's going to be by drawing a line that roughly fits the data. And so if we were to do that with all the data, it might look something like this. Okay, great. But one problem is, now that we've used all the data, we don't have any indication of the uncertainty in this forecasting method. We don't know its accuracy. So as a compromise, instead of using all the data, we're going to use only half the data so that we can do backtesting. So let's pick the last 6 data points. And the forecast might look something like this. And now it's this forecast that we're going to want to get more information on, more information about the uncertainty in this forecast through backtesting. So we'll come back to this particular forecast in a minute. Let's run one of the backtests. So we're going to use the past data to do the same forecasting method. We'll pick half the data, 6 data points, and we'll draw a line just like before. And now, since we're in the backtest and we have some historical data to compare the forecast to, we can measure the error with this little line right here, which is called a residual. It's the difference between the forecast and the actual data. That one's practically 0. Okay. And this residual right here, it's going to be positive, at least as I've defined it, because the forecast is higher than the historical data. And so let's say that this residual is about 3.5. And now naturally there's a bunch of other residuals for all the other points. But I just want to focus on the point that's 1 day ahead of our forecasting data. And then we're going to repeat this process. We're going to repeat this process, but shifting all the data, all the points we're using for the forecast 1 day ahead. So let's pick these 6. Now we pick these 6 data points and repeat our same forecasting method. Might look something like this. And we look at the residuals again. So for now, just the 1 day ahead residual. And this time our forecast underestimated the actual data point, and so we're going to give it negative 4.2. And as you can see, we're going to be repeating this process over and over again. And after it's all said and done, we're going to have 6 residuals for the 1 day ahead forecast. So let's go back to our original forecast that we're trying to get information on. Again, probably it looked something like this. And let's write down all the residuals that we got for 1 day ahead. 3.5 minus 4.2, and then just some other numbers I'm going to make up. Okay, here's all the residuals. And let's draw the points that are associated with our forecast. Okay, so if our forecasting method habitually overestimates the real historical data, then naturally we'd want to skew our forecast down a bit so that it would be more accurate. And the same principle applies if our forecast is habitually underestimating the data. And that overestimation and underestimation is represented in our residuals. So let's say we're looking at the P50. Let's take the median of these data points, and let's say the median was something like minus 0.8. If it's minus 0.8, that means that we're habitually underestimating the forecast. And so we might want to shift our forecast up a little bit. And then it depends on exactly what we're looking for, but we could also look at the P95. And that would probably shift it up like this. Or we could look at the P5 and it'd probably shift it down like this. And now you repeat that process for not just 1 day ahead, but 2, 3, 4, etc. days ahead, based on all the backtesting. And we might get graphs that look something like this. And that's essentially what we were looking at in the previous, in the app. So once again, we've got the P95 of the residuals being represented here, and then the middle is P50 and the bottom is P5. And so having drawn these backtesting adjusted forecasts, we have an idea of the uncertainty inherent in the forecasting method.